Hello everyone. I welcome you all for this lecture series on 4G and 5G communication network. In this lecture, that is lecture number 4, we will briefly discuss about 4G networks. And this is the 4G device. Next, the introduction about the 4G network. The 4G network launched in the year 2012, and it was a significant upgrade to wireless communication technology, offering speeds of up to 12 megabits per second, 12 Mbps. And this network was built on all IP. Here, IP stands for Internet Protocol Foundation, which enabled efficient, seamless communication. The transition to 4G brought about massive changes to both radio and a core network architecture, allowing for faster and more reliable connections. With 4G, users could enjoy high-speed data. This all you know that voice and multimedia services such as video streaming, online gaming, and cloud computing, and paving the way for widespread adoption of mobile broadband and enabling a new era of digital connectivity. Next, we'll move on to the 4G architecture. The 4G architecture is designed with a clear division of functions where the radio function is built on LTE, long-term evolution standards as specified by 3GPP. This 3GPP, I'll tell you what is 3GPP, to manage high-speed wireless communication. Meanwhile, the core network, see here, the core network relies on evolved EPC, evolved packet core standards, also from 3GPP standard, to handle tasks such as authentication, mobility management, and bearer management, ensuring efficient and seamless data transfer. This harmonized architecture enables 4G network to deliver fast, reliable, and scalable mobile broadband services. And here this 3GPP stands for Third Generation Partnership Project. It is a collaboration between groups of telecommunication standard associations known as the organizational partners. The primary goal of 3GPP is to develop globally applicable technical specifications and standards for mobile communication system, including 3G, 4G, and 5G. And this is the 4G architecture. So if you are looking into this architecture, we can look into that is two components, wired component and wireless component. Here the wireless component of 4G architecture include RAN. RAN stands for Radio Access Network and Evolved Node B. This we can call it as Evolved Node B. The RAN connects mobile devices to the network via LTE, long-term evolution, while the E-Node B manages radio resources and communicates with mobile devices. This wireless infrastructure enables mobile devices to access the network and communicate with other devices. Next, wired components. The wired component of 4G architecture include EPC, Evolved Packet Core, and Serving Gateway and Packet Data Gateway, PDN-GW. The EPC manages authentication, mobility, and data transfer, while the SGW routes data packets and from the internet. The PDN gateway provides this PGW provides access to external networks here, external networks, enabling seamless communication and efficient data transfer across 4G networks. Next, we'll move on to the discussion about RAN, Radio Access Network, RAN. The RAN, the Radio Access Network architecture, has undergone significant evolution of 3G to 4G LTE. In 3G, the RAN consists of, that is RAN means what? Radio Access Network consists of base station, node B, and antennas, which provided radio access to mobile devices. However, in this 4G LTE, the RAN architecture transformed into evolved UMTS, terrestrial RAN, EUTRON architecture. This we can call it as EUTRON architecture. And in this new architecture, the evolved node E node B replaced the traditional base station and radio network controller RNC functions, combining them into single entity. This consolidation enabled faster data transfer rates, low latency, and improved network efficiency, and paving the way for widespread adoption of mobile broadband services. Next, we'll see 4G LTE RAN architecture. It includes a significant shift in base station functionality, splitting it into two key components. What are they? BBU, that is baseband unit, and the RRH, that is remote radio head, RRH. The RRH connected to BBU via optical fiber. This BBU connects the RRH with the optical fiber is deployed closer to users in a distributed fashion, while the BBU is hosted in a centralized location, enabling a centralized RAN that we can call it as CRAN. Okay. Architecture. This separation allows for more efficient use of resources, improved network performance, and increased flexibility as the BBU can serve multiple RRH, enabling a more scalable and cost-effective network deployment. Next, we'll move on to E node B functions and sharing. This E node B, a crucial component of 4G LTE, performs a range of functions, including supporting the air interface. That is very, very important. And managing radio resources, compressing IP headers, encrypting user data, and routing user data to serving gateway. That is, we can call it as serving gateway, SGW. Additionally, the E node enables sharing the radio interface among multiple operators, where each operator has separate core network components, including the mobility management entity, we can call it as MME, serving gateway, SGW, and packet data network gateway, PDN, GW, allowing for efficient and secure sharing of network resources while maintaining operator-specific network control and management. Next, we'll see HSS, Home Subscriber Server. It is a central database that plays a vital role in managing subscriber data and profiles in the 4G LTE network. It stores crucial information such as mainly authentication and authorization of the information details, and provides subscriber data to key network components like MME. What I've said, MME, mobility management. This MME stands for Mobility Management Entity and serving GPRS port node. SN means serving GPRS support node. This HSS supports user mobility and roaming by ensuring seamless access to network services and acts as a single repository for subscriber information, enabling efficient management and update of user profiles and facilitating secure and reliable network operators. This is the function of HSS, Home Subscriber Server. Next, we'll move on to Serving Gateway, that we can call it as SGW. The Serving Gateway is a critical network element in 4G LTE architecture. It is responsible for routing and forwarding user data packet. This is very, very important function of SGW, and for acting as a mobility anchor for user equipment and managing user plane traffic and quality services, QoS. It interacts with the packet data network gateway and eNode B to ensure seamless data transfer and support handover and roaming procedure, enabling user to maintain connectivity while moving between cells or network. By managing user data and mobility, this SGW plays a vital role in delivering high quality uninterrupted services to user. Next, we'll move on to PGW, that is Packet Data Network Gateway. This is a pivotal element in 4G LTE network, serving as the point of exit and entry for data traffic and routing user data packets to and from external networks, including the internet and other public data networks, PDNs. The PGW manages quality of services, that is QoS, and charging and billing and ensuring efficient, secure data transfer, and interacts with the key network components like SGW, that is Serving Gateway, eNode B, and external networks to provide seamless connectivity and facilitate communication between users and external networks. And next, we'll see Mobility Management Entity, MME. And this MME is a core network element in 4G LTE architecture responsible for managing critical functions such as authentication and authorization. This is very, very important function of MME, and mobility and roaming procedures and tracking user location and status. This is the main function of this MME tracking. That is tracking and location of the status. This MME interacts with the eNode B Serving Gateway Home Subscriber Server to facilitate session management, enabling user to maintain connectivity while moving between cells and networks and ensuring secure and efficient network operations. By coordinating these functions, the MME plays a vital role in delivering seamless and reliable mobile services to users. Next, the important thing in 4G LTE is PCRF. PCRF means policy and charging rule functions. PCRF, policy and charging rules functions, is a central network component that manages policy and charging rules for subscriber data, making decision on bearer establishment and modification and interacting with the policy and charging enforcement function, that we can call it as PCEF. For policy enforcement, the PCRF provides a QoS, means a quality of service and bandwidth management. This is the main function of PCEF, bandwidth management, and it also provides what? QoS and supports roaming and inter-network policies and enables real-time charging and billing. Additionally, it integrates with other network elements like online charging, that is OCS, online charging system, and offline charging system, that we can call it as OFCS. OFCS means offline charging system. OCS means online charging system, and ensuring seamless and efficient policy management, charging and billing operations, and enabling operator to deliver personalized services and optimize network resources. This is the function of PC RF. Next, we'll move on to the key features of 4G network, and it has got a high-speed data rates up to 1 Gbps, gigabits per second, and has got low latency less than 50 millisecond, and high-quality video streaming and conferencing is possible in this 4G, and it supports for high definition voice and video, and it increased capacity. It has got an increased capacity and scalability, and it has got an improved security and authentication mechanism, and it supports for IP-based servers and applications. Even though it has got many advantages, it has got some disadvantages also. It has got high infrastructure costs for operators, limited coverage in this is the main drawback of 4G. Limited coverage in rural and remote areas, and high energy consumption and carbon footprint, and security risk and vulnerabilities, interference and congestion issues. This is the main disadvantage of this 4G. And a high cost of devices and services for consumers, and limited battery life of devices. Due to why battery life is limited, because it uses the high speed data usage. Then coming to the conclusion. In conclusion, the 4G has transformed the mobile communication landscape by delivering high-speed data rates and low latency, enabling the widespread adoption of mobile broadband and IoT devices. This has led to significant advancement in technologies like video streaming, online gaming, and virtual reality, revolutionizing the way we communicate, work, and entertain ourselves. The impact of 4G has been profound, providing a foundation for future technologies like 5G and beyond. Despite its limitations and challenges, 4G remains a vital component of modern telecommunications infrastructure, continuing to evolve and improve with the advancement in network architecture and technology. As we look into the future, 4G will play a crucial role in supporting the growth of emerging technologies and use cases, ensuring a seamless and connected experience for user worldwide. Its legacy will be felt for years to come, paving the way for even faster, more reliable, and more innovative mobile communication solutions. Hope everyone enjoyed with this 4G technology, and the remaining things we'll discuss in the future lecture. Thank you.